All right, good morning, everyone. Hope you all are having a good day today. Well, that's certainly good to hear. So today we'll be going through chapter 1. Chapter 1's a pretty easy chapter. It picks up a lot in the next couple chapters. We'll start doing ERDs pretty soon. But today's all about talking about what databases are, what data is, that sort of stuff. So here's the topics: databases and applications, purposes of databases, view of data, database languages, database design, database engine, and database users and administrators. So a lot of this is probably going to be a review from systems analysis that you had in the fall. Certainly it's going to be some new stuff as well. So just kind of starting off, talk about what databases are. So in the traditional sense, a database is going to be pretty basic. It's a collection of data. And you may ask, well, data and database, that's in the title. So that may be problematic, okay? So to define data, we have to kind of back up a little bit and talk about information, okay? So data turns into what when it's processed? It turns into information, right? Okay, and then when we apply that information to a problem, maybe to better understand something, what does that turn into? Okay, I don't want to fuss, but participation is 10% of your grade. So it turns into knowledge after it's information once you begin to actually use and apply it. Okay, so data are going to be just like raw points of whatever. Maybe it is a grade database, has a database of grades. Each of those individual grade points by themselves, if I tell you 90.2, you don't know what that means, do you? Okay. But in the context of having it stored and being able to access it, it can turn into information. And then you can interpret that information into knowledge. You can say 90.2, that means they have a pretty decent understanding of what they were evaluated on. Is everyone with me? So that's what we're talking about. We're talking about storing data. Okay, and a lot of the sort of value comes from having it all in one place. It's easily accessible. So if I had a filing cabinet and I had a list of every receipt for a company, while it has the same data as a transaction database would, which one is going to be more valuable to the company and why? Same exact data. Why do you say that? So we can do queries and stuff. We can really gain a lot more information than we can from, at least, let me rephrase it, we can get a lot more information a lot quicker, okay? Same data, but databases are going to allow us to access stuff very easily. We can have lots of data. In this class, we'll be using several databases that'll probably be at least 4 gigabytes in size. If you think about that, that's quite a bit of information, is it not? You're talking about millions of records. You know, think about something like Excel. Okay, does anyone know off the top of their head how many rows you can have in Excel? Okay, I believe it's 1,048,000. Double check me. Okay, but I'm pretty sure that's the number. So, you think about it, we're going to have millions of rows. Okay, we may have thousands of variables. What does that mean? What is a row? Just in general. It's a record, right? So if I have a person table and I have a row in that person table, you can say that's an instance of person. You can say it's a record of the person table. Okay, and accessible. So one of the main advantages of the database is it's not tied down to one specific vendor's application. Well, it shouldn't be. So if you think about a traditional information system you may have seen in the 80s, okay, a common theme was that the databases were really heavily tied down and not easily accessible. So that's why we have stuff like XML, that's why we have stuff like JSON, to easily interchange between different applications using one consistent database. It's going to be a big focus of this class. Okay, a lot of times, and in fact, I would say most times, but not every time, certainly, you're going to use a database management system to manipulate data, especially when you think about it, most of the time, who is inputting data into a database most of the time in an organization? Is it the database administrator? Probably not. Okay, it's probably going to be end users. How many end users do you think would be well-versed in SQL? Maybe 5%? Everyone who leaves my 223 class should be somewhat familiar. Assuming Paul's is the same way. But you would certainly assume not everyone's going to be confident just interacting in a sort of terminal-based way with SQL commands. That's why we have database management systems. The idea behind them is that they provide an easy way to interface with the database. Okay? And they're also supposed to be efficient. Okay, what does efficient mean? It means a lot of things in this context. One of the primary things that it means here is that it is efficient to input information. So for instance, maybe it has stuff like autocomplete. Okay? So if we're typing something out and it automatically completes it, it can just tab over. Is that going to be quicker than manually typing something? Particularly if it's repeated, right? Yeah. Okay. Certainly one example. Beyond that, we talk about the efficiency being that it's not too heavy of an application. Of course, what we mean by that is that it doesn't have too much processing requirements for the task it's doing. Pretty basic stuff there. So some common examples where we may see databases. You all are business majors, especially IS majors. You all should be very familiar with ERP. Okay, who can tell me about ERP? Okay, who can tell me what it stands for? Exactly. So what the ERP system does, and it's probably a review, but just in case, it's sort of a central system to an organization. And this information system comprises many, if not all, functional units inside of an organization. So, you think about all the different functional units, they're all interacting with it. And the main advantage is that that's going to have a shared data warehouse that allows the company to basically share information. Okay, because traditionally, before ERPs were common, you had financing, and you had accounting, and you had manufacturing. And they may all have completely different ideas about what's going on within the organization. When you centralize that, you're going to have a lot fewer information silos. Okay, information silos occur when one functional unit has access to information that others do not. Okay? So by the way, you do want to take notes. I don't see too many people taking notes. I recommend it. But, you do you. So manufacturing, they may need to have specific databases as well. You think about a modern manufacturing plant. Okay, what sort of information are they gathering? They have various sensors all along the manufacturing line. They have certainly quality control. Okay, it's very important they track the quality control over time because that allows them to see things like Kaizen. How are they achieving Kaizen? Okay, Kaizen, of course, being the Japanese word for continual improvement. Okay, so they want to make sure that they're able to track that information over time very well. Okay, then obviously you have web services. It's pretty self-explanatory why they would use a database. They're hosting content, they're providing content. They want to do so as efficiently as possible. Okay, and one of the ways to do it, certainly not the only way, but a very good way is a database. Okay, particularly a relational database for most web services. Now we'll talk about non-relational databases in a little bit. I think that for a lot of cases, non-relational makes more sense. But if you're updating at a relatively infrequent rate, certainly a relational database is going to be a lot more logical of an option. Okay, geographic information systems, GIS. Okay, it's certainly going to be something where there's going to be lots of data points, plotting land, whatever else you do with GIS, you're going to be using databases. And these are just some common examples. Okay, hundreds, if not thousands, of common examples I could have used, but no point in talking, for days about common uses of a database. Okay? So there's really two primary things that databases allow corporations to do. First, it's going to be online transaction processing. Okay, that's where we're processing some sort of transactions. It does not have to be a sale. Okay, transactions are really just, we're seeing what is happening. Okay, then we have data analytics. This is the other primary use. So, obviously with data analytics, there's a couple different types we want to make note of. We have descriptive analytics. So that's describing the data. If you think about you run basic analysis on a data set, you're probably going to start with summary statistics. Look at the distributional patterns of your variables. Look at the mean. Look at the mode. Look at the skew. Look at the kurtosis. Those are all things you're going to be doing in descriptive analytics. All you're doing, you're describing the data that's there. You're not predicting anything, okay? That goes into predictive analytics. So predictive analytics is where we actually go in and we begin to build out predictive models. So for example, regression, logistic regression. We're predicting a binary variable. Just regular linear regression. We're predicting a linear variable. Lots of different things we can predict. Some common ways we can do so. And then lastly, prescriptive analytics. It's where we actually make a recommendation of what should be done. So we've described what is there, we've predicted what will happen, and now in prescriptive analytics we're saying this is what we should do about it. Okay? So it's going to be possibly more qualitative. So for instance, let's say that you are an executive for a company. Let's not use executive. Let's say that you are a mid-level manager and you're describing the data. So you're looking at, let's say you're concerned with profit. And you see that your profit is $2 million. Okay? What else may you be concerned with? How about revenue? Do you think it's fair to be concerned with revenue? I think so as well. So you have $100 million in revenue. Okay? Not the most profitable company in the world, is it? Now, there could be a lot of reasons for that. This is not a finance class, but just to name a few. Maybe the company's reinvesting into itself. Maybe they're a relatively new company. Or maybe their revenue is decreasing. Okay? Just describing what's there, that's descriptive. Okay? We predict what will happen using whatever model we want. Okay, let's say we predict that our revenue is going to go down 1 million. Okay, we predict it goes down 1 million. That's not saying what we should do about it. Okay, that's saying this is what we're predicting will happen. So then, prescriptive is prescribing some course of action. When you visit a physician, okay, they make a prescription for you. What is that? That's them saying, go to the pharmacy, buy these drugs, take them in this fashion. That's them prescribing an action. It's the same concept here. If I said to you, you're going to lose $1 million in profit in 1 year, what do you do about it? What would you do? So there's two things. Think about what goes into profit. Okay? Revenue. What's the other thing? Expenses. So your prescriptive action should either be, or could be more than this, I guess, but in general, you're going to try to increase revenue and or decrease expenses. That's a prescriptive action. Okay, does that make sense? Okay, and then some other techniques we could use for predictive, things like data mining, forecasting, basic techniques. So anything we're doing needs to support the needs of the organization. That's a very important concept in information systems. In fact, if we think back to something like Porter value chain, okay, two major components of Porter value chain. So we have the primary business activity. And, if you look up an example Porter value chain, most likely it's going to have manufacturing. But then there's also support activities. So for most of you, when you go off to a company and you're working there, is your job likely to be a primary business activity or a support activity? Why? Most likely. Some exceptions to that. If you work for a tech firm, specifically something like an MSP, MSP, of course, being managed service provider. In that case, what happens is that a lot of companies will outsource their IT function to MSPs. And particularly for companies, I would say 500 employees or fewer, that can make a lot of sense. Because if you think about it, traditionally, one IT employee should exist for every between 50 and 250 employees, traditionally. I'm not here to say what's right or wrong, but if you think about it, you have 500 employees. Let's say we have 2 IT employees full-time. All right? So, they're working right around 2,000 hours a year. They're going to have sick time, right? They're going to have vacation time. So, if you have 2 employees doing everything, first of all, how are you going to find a generalist like that? Who in here would feel confident in doing desktop support, help desk support, server support, network support, everything? Would anyone? Okay, not to mention, let's face it, smaller companies like that, are they likely to be able to pay, 80, 90,000 to attract people? Are they more likely to be paying maybe 50 to 60? Probably more likely to be paying 50 to 60, right? So an average employee is going to be out about 2 to 3 weeks a year. So if you have 2 employees, it's very possible they may be both out at the same time. You got no IT staff. So if you think about it, it's one of the main reasons that an MSP makes sense. You may pay, let's just say $150,000. And you're going to be getting a completely outsourced IT department. There's going to be lots of contracts, MOUs, SLAs, that sort of stuff. It's all going to be involved. But would you rather pay $150,000 for having a scalable sort of IT department where sometimes you may need to have, but you'll pretty much always have access to the IT department? Or would you rather have 2 employees, which $50,000 to $60,000 salaries, when you add in benefits, going to be around $75,000 per employee. It's going to be around $150,000 anyway, isn't it? Okay? Which one of these would you rather have and why? Why? Okay? Would anyone go for the employees? There can be reasons why you would. I mean, I'm not saying you have to go for an MSP. I think in a lot of cases it will make sense to. But it also depends heavily upon what each employee is doing. Obviously, if you have 500 employees and all of them are using computers for their job 24/7, that's going to be a lot different than if you have a manufacturing facility where only 20 or 30 people are using computers. Okay, so I'm not saying this number is true for every company in the world. It's obviously not. So support the need of the organization. Okay, that's what that's all about. Efficiencies. This is what's most vital about a database. So we talked last class, or I don't remember which class, but we talked in one of my classes about Porter's strategies. Okay, so I mentioned 2 strategies. Cost leadership and differentiation. Okay, so those 2 strategies. And what's very important is that databases can address both of those quite easily. So what did I say cost leadership was focused on? It's focused on competing with their competitors on the price of the good or service, right? In a nutshell. Obviously, there's a lot more to it. Differentiation is focused on what? Standing out, providing a superior or at least different experience. Okay. So those two things databases can help with. Because what we're doing is we're not having a filing cabinet where it may take multiple days to compile a report. We can compile a report in a matter of minutes, possibly seconds. Okay, that's efficiency. We're reducing transactional costs. If we're reducing transactional costs, that can certainly help us with cost leadership, but it can also help with differentiation. Okay, because is it better service to be able to provide an answer in a matter of minutes versus a matter of days? That's much better service. Not to mention, if you're reducing the cost of a support activity, that provides more resources for your primary business activity. So databases are a very good thing. Okay, redundancy. We talked about redundancy a little bit. The idea is that with a normalized database, we're not storing the same piece of information multiple times. At least we're minimizing that. Data inconsistency, we talked about that with the example 123 Sesame Street, where street's spelled out, and street where street is just ST. Okay, so we're reducing that by having it all spelled the same way. And we'll get into how we do that in a couple of chapters. But then data isolation. Again, we've talked about that as well. We're not having the data isolated to one functional unit. We're not having the data isolated to one particular piece of software. It can be accessed freely. Well, relatively freely. I don't mean you should have your database open to the world, obviously. But the point is that it can integrate with many different things. We're not tied down to one vendor. That's a very important concept. In fact, I would say that avoiding vendor lock-in is probably the most important concept of a database. Because if you're ever in a position where you're developing a new system and you have a vendor who's willing to provide services and they're going to lock you in, I would say avoid that if possible. And in most cases, it will be possible. Okay? So that's certainly something to keep in mind. Portability, we just talked about that, where we're not limited to one application. Security. Why is a database more secure? Several reasons. Number one, centrally managed. Okay, something that's centrally managed, certainly would expect the manager to follow whatever policies and procedures exist to safeguard the data. Kind of getting into some IT security topics here. Certainly we can do things like data sanitization. So sanitization of inputs to prevent any sort of attacks, SQL injection, that sort of stuff. And then lastly, ease of access. So ease of access by everyone involved, really. Database administrators are easily to access it, end users, customers. Anyone who needs access can. All right, is that making sense? Any questions about anything? Let's talk about views of data. Okay, so a couple of different views to note. Number one, okay, we have the physical. We're talking about where, in terms of how the storage will actually be done. We're not going to cover that too much in here. That's more of a data structures topic. Any of you guys ever take data structures? I think it's offered here. It's a pretty tough course. Okay, we're not going to go too far into it. Just understand that it's dealing with how the information is stored. Okay? You could be a database administrator and never touch physical. All right? Because guess what? The database will handle it automatically. I mean, it has for at least 20 years, probably longer. Especially relational databases. Non-relational databases gets a little bit more involved with physical, but if you're using a relational database, you don't have to worry about that at all. But in 2022, relational databases are not the only type of database that are used. I would say at most firms they are, but certainly we'll talk about that in a couple slides here. Logical is saying what information is going to be stored. Okay, so we have, certainly all the models. Data models, we'll talk about these up here. And then viewing is just seeing records. It's seeing completed reports. It's seeing, the output. That's the view. All right. So different data models. Obviously, you got the relational model. So the idea behind a relational model, as the name would imply, is we're modeling out the relations between two or more tables. So we may have a student table. We may have a registration table. Student has one-to-many registrations. Okay? But that registration is going to belong to one and only one student. Okay, that's a relational model. And then we throw in the ER model. It's a specific type of the relational model. Basically, it just involves ERD. And then semi-structure, we're not going to cover too much in here. But just understand that it's for non-relational. All right, instances. Let's go back to this picture, though. All right, so you got the physical level down here. Again, it's not a huge focus of this class. We'll probably touch on it a little bit as we go. But mostly, we're going to be concerned with the logical level and the view level in this class. Okay, the logical level being, what information are we storing? How are we modeling the storage? Think about an ERD. An ERD is a logical level view of data. It's a data model. Okay, and then the actual views, like I said, it's going to be the output. It's going to be what information are we receiving from the database. All right, so instances and schema. Okay, instance is going to be, it's going to be the collection of the information that's stored within a database. Okay, so if I have a database, let's just say that it has 500 records in it. Okay, the instance is going to be at a given point. So you guys probably use virtual machines at some point, right? Okay, so when you're using a virtual machine, you've probably at some point taken a snapshot. Okay, so a snapshot is at this particular moment, we can go back and restore it. Okay, very similar to an instance. An instance is going to be at this point in time, this is what information we have. It's not a backup. A snapshot is arguably a backup, although you can make that argument. I'm not going to debate that because it's not even the topic of this class, but you get the idea. Okay, that's what an instance is. Now that contrasts with a schema. Okay, so if you were using, say, MySQL, which I don't think we will in this class, but if you were, and you were to create a new database, it calls it a schema. The reason it does is because a schema is the overall design of the database. Okay, so you have the database. It's basically a schema. All right, it's comprised of both physical and logical aspects. We just talked about physical, and that's how the information is stored. Logical being, of course, what information is stored. So it's concerned with these two layers, right? Does everyone understand that? All right, and then also we can have subschema. So if a schema is a design of the database, a subschema is going to be a design of part of the database, right? So pretty straightforward there. Database languages, there's a couple we're going to talk about in here. The first one is going to be data definition language. And basically it's just a fancy way of saying, how are we creating the database? That's all this is saying. So it's going to specify the schema and additional properties. Okay? So we're building out a database. This is going to be those SQL create statements. Everything you put in there. So you're doing SQL create table, SQL create database, SQL create whatever. Okay? Obviously you don't start all those with SQL, but you get the idea. Create table name, open parentheses. That's all going to be the data definition language. You're defining the database. Okay? In some cases, it may also include stuff about data storage. Not so much in relational databases. This class is going to be primarily focused on relational databases, although not exclusively. Because like I say, non-relational, it may make sense to use them. Okay? This is where you're going to apply your domain constraints. Okay? So, think back to BA 223. We did some examples of this. Actually, I don't think I had anyone in here for BA 223. It might be a 223 class, so I do some examples of domain constraints. Do some examples of referential integrity. So referential integrity obviously refers to making sure that we're fulfilling the schema definitions. So like I say, if I have a student entity over here, and then let's say I have a registration entity. Okay, so they have a relation. Student has one-to-many registration. Registration belongs to one and only one student. Is everyone with me so far? So the referential integrity is going to make sure that relationship stays in place. Okay, so if we think about it, registration belongs to one and only one student. It means we have to have a foreign key on this side of the relationship. So let's just call it stu ID. Okay, it's going to make sure we actually have that. Does that make sense? So this is probably a review. Authorization. We have different user groups. We're going to assign those in a logical fashion that meets the needs of the organization. Then authorization, of course, is going to grant that access. Okay? So we talked about create statements, like I say. That's the DDL part of the SQL is create. So, like I say, we'll do examples of create. We're not going to go into SQL quite yet. But you all remember how to create a table. You literally say create table, name it, put everything you need to inside of that creation statement. Close it off, run it, you have a table now, right? Okay, really straightforward stuff. All right, data manipulation languages. It's a little bit more exciting here. It's not just creating tables. So we're actually inputting records. Okay, we're actually adding, modifying, deleting, inserting, whatever. Okay, so these are the traditional things we think about. So we're retrieving existing records. Why might we want to do that? So get reports, see what we're doing. Exactly. Okay. Inserting new records. Deleting existing records. Modifying records. I think we could all see cases where those may make sense to do. That's what data manipulation language is concerned with. So in SQL, the way they implemented that is the select statement. You're selecting existing information. Insert statement, obviously you're inserting new records. Deleting, and sometimes dropping. Obviously, yeah, it's pretty self-explanatory there. And then update. So you're modifying something existing. Okay, it's going to be primarily concerned with queries. All right, any questions about DDL or DML? Does everyone understand what they are? Like I said, I have the SQL stuff up here. It's not really listed in the book yet, but you've probably done SQL databases before, and I think it kind of helps to sort of visualize in your head, this is the commands that it's actually concerned, or this is the functions rather that it's actually concerned with. Does that make sense? So I hope that helps. All right, database design. You guys have taken systems analysis of design. Is that what it's called here? Okay, good stuff. So what do you start with when you're making a new system? Okay, requirements. So you're going to gather those requirements from the company, from stakeholders, from maybe existing documentation, stuff like that. Okay, then what do? You model. Okay, start modeling. Okay, I don't mean posing for pictures. Okay, talking about conceptually designing a database. So you're going to develop that, and most likely for a relational database, you're going to be using an ERD. Okay. In a couple of units, or a couple of chapters, we're going to be doing those together in class. So that'll certainly be exciting. You guys like ERDs? Okay, I do too. I think they're great. Okay. So that's a conceptual design. And then lastly, we're going to normalize it. Okay? So obviously normalization refers to the process of removing redundancies that may exist within a data model. Okay? And this is just design. So we're not at implementation yet. This is just designing it. Does that make sense to everyone? That's why I don't have creating the table, inputting it. That's why I don't have any of that. Just gathering requirements, building a model, and then normalizing the model. It's basically going through the process. We're going to talk about third normal form and all that stuff in here in a couple chapters, but that's basically the general process. That makes sense? Any questions? Okay, database engine. All right, again, for a relational database, you're not ever going to have to touch any of this stuff. You could be a database administrator full-time. It's pretty much handled automatically, to be honest. But we're going to go over it anyway. Okay? It's basically breaking down the different modules of a database. Okay, so we have a storage manager. That's obviously going to be concerned with having the records stored in a logical fashion. Allows you to access them later. Got the query processor. Okay, that's obviously going to be for the DML functions. Okay, for returning existing records. And lastly, you got the transaction manager. It's going to allow us to sequence operations. Really straightforward stuff. Okay, three major types of database users. Personally, I think calling a user naive, I think that's a bit insulting. Okay, if I were someone, I wouldn't want to be called naive. But hey, the book calls it naive users. I would personally use the term end user. Okay, I think end user is going to be a lot more friendly of a term. Okay, imagine if I walked in here and I said, boy, what a good group of naive students. Okay, who would be a little bit offended by that? You'd probably think it was a strange thing to say, but you may also be a little bit offended. So I wouldn't use that term in a professional setting. Okay, I would use the term end user. End user is a lot more professional of a term, is it not? Okay, but basically they're end users. They're the people who are using the database. They're not a programmer, and they're not a sophisticated user again. I think that's a silly term too. If I walked in here and said, my, you all are one group of sophisticated students, you'd think I'd lost my mind, wouldn't you? Okay? I would use the term database administrator, because that's what they are. So again, I don't necessarily like these two terms, but they're in the book. If I don't like something that's in the book, am I going to test you over it? No, because I'm not a ridiculous person, am I? Well, don't answer that, but I don't think I'm a ridiculous person. Okay, so sophisticated user. It's going to be a database administrator. Naive user is going to be an end user. Application programmer is going to be someone who's developing an application, obviously. All right, so the database administrator, primary stuff they're doing is they're maybe creating databases, but more likely, their day-to-day is going to be maintaining existing databases. Okay, maybe they're running reports. Maybe they're doing other stuff. But some common things they may be tasked with, things like schema definition. A lot of documentation, probably. You know, think about stuff like a data dictionary. Whose job is the data dictionary? It's the DBA's job, right? So obviously, data dictionary. Have you guys done one before? Okay, so it's just going to be a table of all of your tables within the database. So it's going to have your column names. It's going to have your column description. It's going to include data type, and maybe where the data comes from, depending on how large the database is. Okay? Certainly they're going to be the primary person involved with modeling the database, so making the schema definition. Updates. Now, when I say updates, I don't mean inserting new records. Okay, that's not likely a database administrator's job. They could be doing it in bulk. That is possible. They could be writing a script to do some XML stuff, maybe some JSON. That's certainly within the realm of possibilities. Okay. But more likely what I'm talking about is updating the actual database itself. So let's say you're using a Microsoft SQL Server. Okay. You're running Microsoft SQL Server updates. Does that make sense? That's what I'm talking about with updates, not updating the actual information. Let's go through some brief history. Okay, any history buffs in here? Well, it's a different type of history. Tricked you there. So the 1950s, we had magnetic tapes, punch cards, and sequential processing. So sequential processing, what that means is that it's in the order that it's stored. So that can be good and bad. That's not going to allow us to do a select statement, is it? We can't select stuff based on a criteria with sequential processing. It's like we have a sheet of paper. We can only read it line to line. We can't go this line, then this line, then this line. You have to go in the order it's stored. 1970s, we got hard drives, network and hierarchical data models, and then most importantly for this class, we had the COD relational model. Okay, it doesn't mean that they're relational databases yet, but he went ahead, actually I think there's a couple if I'm not mistaken. They went ahead and developed the relational data model. Not a relational database, those came in the 1980s. Okay, so we've been using relational databases for 40-something years. Is that kind of cool? I think it's kind of cool. So 1990s, we got structured query language. Application integration became a big thing. Certainly, whole purpose of a SQL database is to be integrated with many things, not to be limited to a single thing. So it kind of came about in the 2000s. And these timelines are approximate, by the way. We got XML and JSON. And lastly, 2010s, we got NoSQL. Well, I'm not going to say it began in the 2010s, but its use widely expanded. So why did NoSQL widely expand in use? That's a good question. Okay, primary reason is relational data models and relational databases specifically, there's a lot of inherent overhead with the processing of them. So let's say a company like Uber. Uber uses a non-relational database. The reason they use such non-relational database as opposed to a more traditional relational database is that Uber wants to provide lots of rides. Okay, so how many people do you think take Uber every day? Probably millions, right? And, they're not just collecting information about saying this person is taking this ride. They're collecting information the entire ride. Do you guys understand that? So if we have a car, let's just say this is a road. Okay, we have a car. I'm not an artist, okay? I have a car going down the road. It's transmitting information to Uber. Okay, that information is stored. And then over time, as they build out that information, that tells them a lot of things that are very important to the pricing of rides, right? What things may it tell them? I'm sorry? So the distance, yeah, that's going to be given. But, more importantly for pricing, what may it tell them? So duration, that's going to be important. And it's also going to tell them different times. So it's going to basically approximate traffic. So for instance, Durango is probably not a good example of this. In most big cities, you think it's going to be quicker to go home at 5 p.m. or 7 p.m.? And why? Why? Exactly. So having that information down to, in some cases, even the minute, is that not hugely advantageous? So that's going to be over the course of a ride. It may be thousands of database updates. Multiply that by millions. That's going to be quite a bit of overhead, right? That's why they use NoSQL. Amazon uses non-relational databases. Okay, and there's a lot of different types. NoSQL is a general term. Okay, there are several different commonly used non-relational databases. We're going to talk about those in the last bit of class. Not this class, but I mean a later class period. So the last little bit of the semester, I should say. But they have a lot less overhead. Having said that, they also have some disadvantages. It's more difficult to use them. Okay, relational databases are pretty easy. I hope you would agree with that. Okay. Modeling out a relational database, I teach it in 223. I'm not saying that course is easy, but I'm saying it's something that most people can understand with relative ease. Non-relational databases, it's not so easy. Okay. There's not pretty little relations present. Okay. queries can take a lot more time, but the overall use is a lot more efficient if you have, definitely more than millions. I would say it's in the realm of like billions of transactions per day. Non-relational is the way to go. Does that make sense? So we're not really going to have anything in this class that's going to need a non-relational database, okay? Because just to be quite frank with you, you guys know the server rack I have in the lab there? If every one of those servers were running and I had that full processing power, it wouldn't be anywhere close to what I would need for you to make sense to use a non-relational database. You're talking about some of the biggest companies in the world. Okay, that's when it begins to make sense. For a smaller scale, relational makes sense. Does that make sense? And it's really about the frequency of update. The more often you insert new information, the more likely it is that a non-relational database makes sense. All right, got a task for you all. I want you to pair up with someone close by. You might have to move around for this. Someone absent today? Or can I not count? Oh, we got 11 people in here, right? Huh. Yeah, that's right. We do, in fact, have 11. So how about we do this? How about you two pair up? How about you two, you three, and then you two? Is that good? So think about a company. You don't have to do a ton of research for this. I'll give you about 5 or 10 minutes. I want you to come up with some possible tables and fields they may be interested in. And then once you've done so, I'm going to have you informally present to the class. So go ahead and do that. Take about 5 or 10 minutes.